A very good morning, students. So this is my next video tutorial on the next chapter, that is chapter 3, force and pressure. So in our junior classes we have already learned what is force. Force can be either be in form of push or a pull. So whenever you are applying a force on any stationary object, the object gains momentum or the object starts moving. But whenever a object which is already in motion, when you apply a force on that object, the object starts or comes to a stationary point, it comes to rest, right? So you see, whenever we are applying a force on any object, let us consider a table. When you are applying a force on a table, the table moves in a direction your application of your force, means in which direction you are applying the force, the table starts moving there. So when you are applying a force on its center of mass, that is the geometric center of any object, the object starts moving in a specified direction, that is in a direction of force. But think, if you are applying a force on any object not in the center of mass, not in the center of any object, like if I say, if this I consider a book, now this is the center of mass, right? This is the center of mass here. So if you apply a force in any other direction apart from the center of mass, the object will not move in a given direction, it will start rotating. That means whenever you are applying a force apart from center of mass, the object starts rotating in other direction. So this is called torque. So that is the other name of moment of force. So what is torque? Torque is the rotational force. So whenever you are applying a force and the object starts rotating, that means you are applying a torque, and that is being measured in terms of moment of force. Now let us see what is torque. The turning effect of force is called moment of force or torque. So basically torque is also a force, but whenever you are applying a force on any object and the object starts rotating in a variable direction, so we consider it to be as moment of force or torque. So torque can also be defined as the moment of force is the product of force and shortest distance. That means this moment of force or the torque, it depends upon two factors. It depends upon force, that means if you apply more force, the object will rotate more faster. Now if you are applying a force on any object and it is having large distance from the point of application, then also the moment of force will be more. So the moment of force is the product of force, that means it depends upon force, and the shortest distance from the pivot to the point of application of the force. That means it depends upon distance and it depends upon force, right? So let us see one example. Let us draw one door here. Let us consider this is the door and the knob is connected here. That means you need to open the door by rotating this handle, right? Now this is the hinge. This is the hinge, or you can consider this is the wall, right? So in order to open this door, if you are applying a force here that is very close to the hinge, that means this pivot or the axis of rotation and the force of application is very less, that means this distance is very less, that means you need to apply more force. That means more force you have to apply, it will be difficult to open the door. But same in the other case, if you apply a force that is having a far distance from the hinge, then you need to apply less force. That means moment of force in this case will be maximum, moment of force in this case will be minimum. So whenever I say moment of force will be maximum, that means it will be easier to open or rotate the door, right? But if I consider here moment of force is less, that means it will be difficult for you to open the door, right? You see in your screen there are two books. In one case, when you are applying a force on a book, the book starts moving in the forward direction. But whenever you are applying a force in other part apart from the center of mass, then the book starts rotating. So this rotational force is called torque, right? So different object has a center of mass at different position. You see circle, this is the center of mass. This is square, the diagonals where they intersect, that is the center of mass, and this is the center of mass where the centroid meets, right? So whenever you are applying a force on the center of mass, the object will get balanced. But apart from center of mass, if you are applying any force in any part of that object, the object will start rotating. This force which is applied on that object is called torque. You see, a boy is opening the door and he is opening at the edge, right? So it is a maximum distance from the hinge. So if it is at maximum distance, then less force will be applied to open the door. Or you can say, larger the distance from the pivoted point, the greater is the turning effect of force. Turning effect of force will be maximum. This means the less force will be applied to open to the door. That will be less difficulty to open the door. So that means torque depends upon two factors. One is force and one is perpendicular distance. So it is denoted by tau. Okay, this symbol is known as tau, TAU, right? So what is the SI unit of tau? SI unit of tau is Newton meter. So Newton is for force and meter is for distance. So Newton meter is the SI unit of tau. Now if I ask what are the factors upon which this torque depends, this torque depends upon two factors. It depends upon magnitude of force. So if you apply a more force to rotate that object, the object will be rotating more faster. And also it depends upon the perpendicular distance. Just now I have given one example of opening the door. That means if the hinge is having a far distance from the point of application, that means here you are applying the force and this is at far from the hinge, then the moment of force will be maximum. This indicates that there will be a less difficulty to open the door. But in case if you are opening the door and the hinge is very near to your point of application, then we will consider that force needed is maximum, or you can say less moment of force is produced here. Okay, so these are the factors. So two factors upon which the moment of force depends. It depends upon the strength of the force applied and perpendicular distance from the axis of rotation. Okay, so these are the two factors upon which moment of force depends. So these are the two factors affecting the moment of force. First you see strength of force applied and perpendicular distance from the axis of rotation or the pivoted point. Okay, so these are the two factors you need to write in your exercise book. So you see in the diagram there are few examples in form of picture. A boy is opening the door which is having a maximum distance from the hinge. A boy is opening the lid of a bottle. A boy is using a sharpener. So if the length of the pencil is bigger, then he need to apply less force, but if the pencil is very small, then he has to apply more force. So simply it means if the length of the pencil is more, then more moment of force will be produced, but if the length of the pencil is small, then less moment of force will be produced. So less moment of force means more difficulty, right? It also depends upon the steering wheel. If the steering wheel is small, then less force is required, and steering wheel is big, that means more force is required, okay, to rotate the vehicle. So that is why in truck and all we see that the length of the steering wheel is very large to increase the force, right? That is to increase the moment of force here. There are a few common examples of torque. You see, as mentioned earlier, it is difficult to tightening a screw with hand, whereas it is easily done when we use a spanner. When a spanner is used, we are actually using the turning moment of force to our advantage. The distance between the pivoted point and the force gets increased when we use the spanner, and therefore the moment of force becomes greater. This means this is a spanner, right? Generally we call in a common language that is a range. Now if the length of this spanner is long, then more moment of force will be produced. That means there will be a less difficulty to rotate. But in case if the length of the spanner is small, then less moment of force is produced. That means it will be more difficulty, right? So first it depends upon the perpendicular distance from point of application. That means you see 30 Newton, that means force is applied here and it is having a maximum distance from the point of rotation. That means here fulcrum, you can consider this one as fulcrum, and this is the point of rotation. If it is at maximum distance, less force is required. If it is minimum distance, then more force is required. So this was the first example of torque. Second example, you see the opening and closing of doors with hinge is another example of turning effect, which already I have explained. That is, you can give as second example. Third, twisting the lid to open or close the jar. It is also an example of application of torque. And similarly, turning a water tap also shows the turning effect of force. Next, when you hold and turn a pencil inside a sharpener, you apply the turning effect of force. That means that sharpening a pencil is also an application of turning effect of force. And a driver applying force on the edges of the steering wheel. This is also an example of turning effect of force. So these are the 5 examples of turning effect of force which we use in our day-to-day life. You see, one solved numerical is also there. A spanner is used to unscrew a nut, a force of 30 Newton. That means the force mentioned here is 30 Newton, which is applied to the end of the spanner, which is 10 centimeter away from the center of nut. Calculate the moment of force when the spanner is horizontal. So we need to calculate here torque, that means tau we need to find here, and formula is F into D. Force is how much? 30 Newton and D is 10 centimeter. So it is in centimeter, but if you need to get answer in SI unit, you need to convert centimeter to meter. So 1 centimeter is 1 by 100 meter, so 10 by 100. 1 0 and 1 0 will get cancelled, that is 0.1 meter. So distance is 0.1 meter and force is 30 Newton. So in order to find here torque, F into D, we will substitute the value of force and D in the formula, that is 30 into 0.1. Now if the point will get reduced, then 10 will be coming down, so 0 and 0 will get cancelled, so 3 will be left, that is 3 Newton meter. So what is the torque which is used to rotate the spanner to unscrew a nut? That is 3 Newton meter. So force also depends upon pressure, or you can say pressure depends upon force. So these two terms are correlated with each other, right? So pressure, it is defined as the force acting normally on the unit area of a surface. That means pressure means here force acting per unit area, and the force which is applied normally on the surface, or a perpendicular force applied normally on the surface, is called here thrust. So pressure, you can say thrust per unit area, or that is force per unit area. So what is the SI unit of force? That is Newton. And what is the SI unit of area? Meter square. So pressure equals to Newton per meter square. You can write as SI unit, or you can also write Pascal, right? PA is denoted as Pascal. So the SI unit of pressure is Newton meter square, or in a Pascal. And if you see, if I say how area and pressure is related to each other, if the area of cross section is more, the pressure applied will be less. Similarly, if area of cross section is less, then pressure applied is more. So let us give one example. See, the school bags which we carry, if the strips are having broad, that means it will exert less pressure on your shoulder. But in case the strips of your bags, if it is very thin, then it applies more pressure, that means it exerts more pressure on your shoulder. So from this example we come to know that this pressure and area, they are inversely proportional to each other. That means if area of cross section is more, then pressure applied will be less, and vice versa. Similarly, a knife, if the knife is very sharp, if the edges are very sharp, then it will be easy to cut. For cutting it will be very easy. But in case if the knife is very blunt, then you have to apply more force, and you will face any difficulty in slicing the object, right? So in the screen you see if force is being applied on a ball, so with the help of thumb, so the force which is applied normally, that is called thrust. So therefore pressure equals to thrust per unit area, that is force by area. The unit of pressure is Newton per meter square. It is also denoted by Pascal, that is PA, right? So therefore pressure depends upon two things, that is force acting on the surface and area of surface on which the force is acting. So you see the example on your screen. For example, if you press your thumb against a piece of paper, you would not be able to make a hole in the paper. However, if you press the pointed end of drawing pin against the same piece of paper, you will be able to make a hole in the paper. So this example says that if you are using a needle in order to pierce a paper, then it will be easy for you to pierce. But same paper, by applying a same force, if you try with your finger, then you will face difficulty, right? Or the object will get heavy force and it may turn widely. So this is a relation on applying same force. If you are applying more area, if the area is more, then you need to apply less pressure. But in case if the area is less when you are applying the force, then you have to apply more pressure. So this is the relation between pressure and area. You can see a solved example also. On the surface of block, if it weighs 60 Newton and is lying on the side with area 0.3 meter into 0.1 meter, you see force is given 60 Newton and length and breadth is given. So you need to calculate here pressure, right? Pressure we know, force per unit area. Force was given 60 Newton and area is given 0.3 into 0.1. So after multiplication, you will be getting 2000 PA. That means 2000 Newton per meter square, or in place of Newton per meter square, you can also write 2000 Pascal. Same, there was another question. On the same 60 Newton block, if it is lying on a side within area 0.1 meter and 0.2 meter. So force in the second case is 60 Newton and length and breadth is 0.1 into 0.2. So here also we have to calculate pressure. So pressure equals to force by area, that is 60 by 0.1 meter into 0.2 meter. So after calculation, you see 60 by 0.02. Again, if you divide 60 by 0.02, if you remove the point, 100 will be going up, then you cancel, you will be getting 3000 Pascal, right? So this is how we will be solving numericals based upon these two formulas. One is of torque and one is of pressure. So till then, see you in next video. Thank you.